Okay, these are the syllabus statements that I want us to look at within this video. And as you can see, the extension bit means this is triple material. So it's quite important that we really get a good handle on this. So we know what gas exchange is. Gas, remember, the carbon dioxide and the oxygen are going to be exchanged at the leaf surface. Also, we need to think when we're talking about gases moving in and out of the leaf to consider water and an idea called transpiration, but we'll come back to that later on. We're interested here in this gas exchange being between carbon dioxide and oxygen. Now remember that carbon dioxide is produced from respiration, oxygen is produced from photosynthesis. Now one of the things that people often get muddled up with is the fact that if plants are doing photosynthesis, they're not doing respiration. It's really important that you understand that plants are doing respiration 24/7. They're doing it all of the time. And if the plant is doing respiration and it's producing carbon dioxide, the carbon dioxide is fed straight into photosynthesis. But usually the plant is going to try and do as much photosynthesis as is possible, so it's going to take in even more photosynthesis. But what this is talking about here is the net effect. Okay, the overall effect of the gas exchange of carbon dioxide and oxygen in relation to respiration and photosynthesis. So we need to think about if respiration is going faster than photosynthesis, what's the balance of the gases there? And then the same thing, if photosynthesis is happening at a faster rate than respiration, what's going on? Now we're going to use an indicator to do this, and the indicator is called hydrogen carbonate indicator, which is the same thing as bicarbonate indicator. And like all indicators, it's going to show us a change. It's actually measuring the change of pH. Now, most atmospheric gas will be this kind of color. So if you've got a sealed container and you've got... Okay, so in this video, we're going to look at these two syllabus statements, and the extension part there is signposting to you that this is triple material, so it's a little bit more involved. So the first one says, understand gas exchange, and we're talking specifically here about the exchange of carbon dioxide and oxygen gas into and out of the leaf. And remember that carbon dioxide is going to move into the leaf so that the leaf can do photosynthesis, but also the leaf cell will be producing carbon dioxide because it's also doing respiration. Similarly, oxygen gas is going to be needed in leaf cells for respiration, but it's produced by the cells of the leaf when that cell is doing photosynthesis. Now, it is a common mistake to think that when plants are doing photosynthesis, they're not doing respiration, and that's not quite true. All plants at all times and all of the cells within them must be doing respiration 24/7. But sometimes the rate of respiration is lower than the rate of photosynthesis and vice versa. So what we need to understand is the net effect. That is the overall effect of the direction of the gases into or out of the leaf, depending on the rate at which these two processes are taking place. So if respiration is taking place faster than photosynthesis, then that plant is going to need more oxygen taken into the leaf. And if photosynthesis is taking place at a faster rate than respiration, all of the carbon dioxide that is produced in respiration will be fed into photosynthesis, but it needs more, so more carbon dioxide would move in. So what we're going to do is use what's called a hydrogen carbonate indicator, and the hydrogen carbonate indicator will change color depending on the carbon dioxide levels, or actually more specifically the pH. So what we need to consider here is the experiments that I'm going to show you in a moment are going to all be in a sealed container. So the lid must be firm tight, and we're going to place different scenarios, different organisms within the solution here. Now, at normal atmospheric gas, so if you have normal atmospheric gas inside this seal tube here, then it will dissolve into the hydrogen carbonate indicator, and it will give it this characteristic red color. Now, what you'll see here is a change in color as the pH changes. Now, we need to think that if carbon dioxide levels are increasing, then they will be increasing because something in here is producing carbon dioxide, i.e., there are organisms in here doing respiration. So if you have a snail inside here, then that snail will be, it's an aquatic snail, so it's perfectly able to live there. It's not damaging to the snail at all. But if the snail is in this sealed container, the snail is going to do respiration. The levels of carbon dioxide inside this sealed tube will get greater, and the indicator will show you this change here. As the more carbon dioxide that is dissolved, it will dissolve to become carbonic acid, and the pH changes in this way. In the same way, if we've got a plant material inside here, and it's an aquatic plant, so again, it's able to survive in here, and with the lid is closed, and we shine a bright light on that plant is going to do a lot of it's going to do a lot of photosynthesis. Now, it'll still be doing respiration, but if you shine a bright light, it'll be doing a lot of photosynthesis, more photosynthesis than it will be doing respiration, which means that overall, you're going to decrease the carbon dioxide levels in here because you're going to take in the carbon dioxide for photosynthesis. And that's going to cause, again, the indicator to change color, and it's going to become more alkaline this time because of the decrease in carbon dioxide. So there's less carbonic acid in solution. So I suggest that you pause the video at this stage and see if you can re-explain what I've just done. Okay, let's have a look at this setup here. So in this particular boiling tube, what we've got is a boiled leaf. So the boiled leaf is a dead leaf, and dead leaves are not able to do respiration, and neither are they able to do photosynthesis. So if you leave it set up like this, and this arrow here is meant to represent a light, you've got plenty of light is coming from all different directions, and this is your hydrogen carbonate indicator solution, and it's going to stay red over the course of time because there's going to be no change in the carbon dioxide level within this tube. And again, can I just draw your attention to the fact that this is a sealed tube? If we compare it to this one here, what we've got is a leaf. We've got lots of light coming from all different directions, which might not be necessarily clear, but we've got an even light source. So what's going to happen here? Well, the leaf is going to do respiration. It has to do respiration, remember, 24/7. But because you've got plenty of light, the rate of photosynthesis is going to be greater than the rate of respiration. That's what this symbol here means. It's greater than, which means that the level of carbon dioxide in this sealed tube is going to go down. You're going to need more carbon dioxide moving into the leaf to do photosynthesis. And here you've got the associated change in the hydrogen carbonate indicator solution. If we jump down to this one, first of all, we've got exactly the same setup here, but the aluminium foil is going to mean that you don't have any source of light, which means that the rate of respiration is now going to be greater than photosynthesis. Photosynthesis can't take place without a light source. And what we've got in this case is more carbon dioxide being generated in the tube because of respiration and the associated change here in the leaf tissue. And finally, let's look at this one here. Now, in this case, what we've got is tissue paper, which is decreasing the intensity of the light. So you've got less light, and remember, in this case, light might now be the limiting factor. And what can happen is that the rate of respiration and the rate of the production of carbon dioxide is equal to the rate of photosynthesis, which means that all of the carbon dioxide that's produced is going to get used here, but the rate of photosynthesis is going to be exactly the same as that produced from respiration, in which case there's going to be no net change of carbon dioxide gas here. And in this case, again, the indicator is going to remain red. So what I want you to do next is to review the pages that are indicated here of the textbook, make some extra notes, try and complete the booklet. You obviously can't do the practical sections, but you should now be able to bring questions to me about things that you have difficulty with, and try and aim to finish the booklet. We'll have more time on this in tomorrow's lesson too.